What's up everybody, Mr. Martin here with an Introduction to Engineering Design lecture on the properties of geometric solids. We're just going to review a few fundamental things, do some examples, and get you guys going. So the first thing we're going to talk about is, what is a solid? Well, a solid is a three-dimensional object. In sketching, two-dimensional shapes are used to create the illusion of three-dimensional solids. So what you're seeing on the screen right now with the cube and the cylinder aren't actually 3D, but we can use an illusion of sketching to make it seem 3D. And there are various properties of solids that you need to know. So its volume, mass, weight, density, and surface area are the properties that all solids possess. These properties are used by engineers and manufacturers to determine material type, cost, and other factors associated with the design of objects. So the volume refers to the amount of three-dimensional space occupied by an object or enclosed within a container. So in this class, we measure volume using cubic centimeters if we're in metric, or cubic inches if we're in the English system. And those can always be converted into other units if we need them to be. So for example, we have a cube that has sides of equal length. Here we have a cube with a side length of 4. The formula for calculating the volume of a cube is side cubed. So we'd do 4 times 4 times 4, which would give us a volume of 64 cubic inches. Similarly, we could find the volume of a rectangular prism. A rectangular prism has at least one side that's different in length from the other two, so we have width, depth, and height measurements. And we can find the volume of a rectangular prism by multiplying the width, depth, and height. Here the volume would be 4 inches times 5.25 inches times 2.50 inches, which would give us a total volume of 52.5 inches cubed. We could calculate the volume of a cylinder given its radius and height. The formula for calculating the volume of a cylinder is pi r squared times h. So here we have a cylinder with a radius of 1.5 inches and a height of 6 inches. And we can plug that into the formula. So using 3.14 as our approximation for pi times 1.5 inches squared times 6 inches gives us a volume of 42.4 cubic inches. We can similarly find the volume for a cone given the radius and given the height of the cone. And the volume of a cone is given by pi r squared h over 3. In this example, we're given the diameter of the cone to be 1.5 inches, so we need to make sure to divide that by 2 to find the radius before inserting it into our equation. So once we've done that, we can find the volume to be pi times 0.75 inches squared times 2 inches divided by 3, and the volume is 1.18 cubic inches. So you do have access to a formula sheet, and the formula sheet has these volume and surface area equations on them for you. For cube, rectangular prism, right circular cone, pyramid, irregular prism, cylinder, and sphere. So let's transition into talking about mass. And mass refers to the quantity of matter in an object. It's often confused with the concept of weight in the SI system. We've talked about this at length in our previous video. In the SI system, the unit for mass is the gram. In the US customary system, it's slug. Weight, on the other hand, is the force of gravity acting on an object, and it's often confused with mass in the US customary system. In the SI units, we have the Newton. In the US customary system, we have the pound. And contrary to popular practice, the terms mass and weight are not interchangeable and do not represent the same concept. So weight is equal to mass times gravity. So weight in pounds equals mass in slugs times acceleration due to gravity in feet per second squared, where g is about 32.2 feet per second squared. An object, whether on the surface of the Earth, in orbit, or on the surface of the Moon, still has the same mass. However, the weight of the object will be different in all three instances because the magnitude of gravity is different. Each measurement system has fallen prey to erroneous cultural practices. In the SI system, a person's weight is typically recorded in kilograms when it should be recorded in newtons. So if you were to go to another country and you ask somebody how much they weighed, they would probably tell you in kilos, which is not a unit of weight. They should say how much they weigh in newtons. In the US customary system, an object's mass is typically recorded in pounds when it should be recorded in slugs, but nobody ever uses the word slugs. That brings us to density, and there are two types of density that we use in this class. First is mass density, which is an object's mass per unit volume. In the SI system, that's grams per cubic centimeter. And weight density is an object's weight per unit volume. In the US customary system, that's pounds per inches squared. In the US customary system, that's pounds per cubic inch. Here we have some examples of density. You can see what the densities of some common objects are that you might encounter either in everyday life or while you're doing engineering work. So if we know volume and we know density, we can find the mass of an object. So to calculate the mass of any solid, its volume and mass density must be known. Here we have an aluminum block, specifically an aluminum 6061 block, where the density of that material is 2.71 grams per cubic centimeter. It's a rectangular prism, so we can calculate its volume based on the given values. So let's go ahead and try this one on our own, and then after the video resumes, go ahead and check back in and see if you got it correct. So if we plug in our values into the formula, we get that the volume is 3.81 centimeters times 8.89 centimeters times 17.28 centimeters. We can multiply that by the density of 2.71 grams per cubic centimeter. We put that into our calculator and we get a value of 1,586 grams, or 1.59 kilograms. So we could similarly use weight density to calculate the weight of any solid, given its volume and weight density. So we have the same block of aluminum that has a weight density of 0.098 pounds per cubic inch. We know the volume from the previous problem is 36.75 cubic inches. And the weight density is 0.098 pounds per cubic inch. Put that into our calculator, we get 3.60 pounds. Next, we're going to talk about the difference between area and surface area. Area describes the measure of the two-dimensional space enclosed by a shape, while surface area is the sum of all the areas of the faces of a 3D solid. So in order to calculate the surface area of a rectangular prism, the area of each face must be known and added together. We could unfold this rectangular prism into a net and find the individual areas of all 6 faces. Then we could add those areas together and find the total surface area of the rectangular prism, which is 136 square inches. Another way to represent the formula for surface area of a rectangular prism is given on the formula sheet, and that's 2 times width times depth plus width times height plus depth times height. If you want to use that formula, you're more than welcome to. In fact, we're going to do an example that uses this formula right now. So we have this rectangular prism that has a width of 8 inches, a depth of 4 inches, and a height of 3 inches. So go ahead and pause, calculate the surface area of this rectangular prism, and then check your answer when you press play again. So the surface area is 2 times the quantity, 8 times 4 plus 8 times 3 plus 4 times 3, which is 136 square inches. Now let's take a look at this green rectangular prism that has a width of 4 inches, a depth of 5.25 inches, and a height of 2.5 inches. We can use the same formula that we used in our last example. Go ahead and try this one on your own, and then check back in a minute for your answer. That all equals 2 times 44.125 square inches, or a total surface area of 88.3 inches squared. Finally, we're going to calculate the surface area of a cylinder. The area of the curved face and the combined area of the circular faces must be known. The formula for finding the surface area of a cylinder is 2 pi times r times h plus 2 times pi r squared, where pi r squared is the area of each circular face and 2 pi rh is the area of the curved face. So why don't you go ahead and try this example where the radius is 1.5 inches and the height of the cylinder is 6 inches, and solve this on your own. Press pause, and when you come back, check and make sure that you got this right. So we plug in our values and we get that the surface area is equal to 2 times pi times 1.5 inches times 6 inches plus 2 times pi times 1.5 inches squared. Simplify that a little bit, we get 56.55 square inches plus 14.14 square inches. Add those two values together and we get 70.7 square inches. I hope you found this video helpful. If you have any questions, make sure you shoot me an email and I'll hopefully see you soon.